Alright, so welcome to Academic Logics class. Today we're going to be treating half-life of a first order reaction. Remember I told you that concentration here, this is for first order reaction, this is the concentration for a given time, at a given time. Then this is the concentration, initial concentration. And what we have here, this whole expression is the equation for a first order reaction, the integrated rates law for a first order reaction. So whenever you want to get the half-life, you use the integrated rates law equation. And I told you that as you do as reactions go on, it tends to move from the initial concentration towards a point where it disappears. So, but when we now talk about half-life of a first order reaction, it simply means at what point did the initial concentration get to half. So inside this, we are going to be having the initial concentration divided by 2. So this is going to simply be the same as ln A naught for initial concentration all over 2. So the idea is always to convert this A at given time to initial concentration over 2. So once you are with that idea, you are good to go. So equals to minus k t, and the t here is half, that is half-life, time to get to half of it, plus ln A naught, initial concentrations. So what I'm going to try to do here is to simply, how do I make the subject of the formula? So I need this one to cross over, so this becomes ln A naught over 2 minus ln A naught, that is initial concentration, is equals to minus kt half. So you can very well see that this lane is natural log. Anytime you see this lane, some of you, when you see it, you feel it's strange. No, always treat it the way you treat logarithm. And there's a law in logarithm, division law, that says that whenever you have a log and another log, so far as they are having log, that you can simply divide. So this is the sentence saying lane one side. You can just make, since they have lane and lane, you can just make it just one lane, then divide. So this becomes lane A naught divided by 2 all over A naught. So it's law of logarithm equals to minus k t half. So notice that if that is the case, let's analyze this thing that we have here, this whole expression. Let's analyze it. You agree with me that this is the sentence saying I have A naught over 2, then divided by A naught over 1, which means that this is the sentence saying A initial concentration over 2 times 1 over. So notice why I did it this way, so that you see that it is not the same thing as when I have A over B over C, that is dividing this with this. No, rather it is I have something of A over B and all of it is being divided by C. Always get that point, the difference, so you don't confuse it. So this is going to be the sentence saying A naught all over 2A naught, or you say 2 initial concentration. Now remember that it's carrying lane, so let me just bring the lane. So lane equals to, everything here is equals to minus k. Let me just bring all of it down, because some of you, once you skip a step, you get scared. So notice I have A here, I have A here, I have not. This can take care of this. That means there's 1 up here. So this is now ln 1 over 2 is equals to minus k t half. Minus k t half. And you need to know that this is the sentence saying ln 2 raised to the power minus 1 is equals to minus k t half. Reason is indices. Anytime 1 is the numerator, it means that it's raised to negative power. So logarithm says that if you have a power, if you have the log of a number or a log of a variable raised to a power, that power can come and multiply. So this is something that's saying minus 1 ln 2. And you know that minus 1 is something as minus ln 2 is equals to minus k t half. So at this point, I can say there's minus here, there's minus here. The minus is cancelled out. So I have ln 2 is equals to kt half. So I can say divide both sides by k. So I have divided by k divided by k. K will cancel k. So that I have t half. The half-life is equals to ln 2 over k. And this ln 2, you see it sometimes in textbooks, they punch it to be 0.693 all over k. So even when we start doing radioactivity, we'll be making use of things like this. So this is how you get it. Very sweet. Academics is interesting if you are serious. So there you have it.